Okay, good morning, ladies and gentlemen. Today we're going to do lesson 6.2. It's called Modeling with Polynomials. Basically, what it's doing is it's doing regression lines. Back in Algebra 2, you guys used to do best fit lines and stuff like that. Well, now we're going to start doing not only best fit lines, but best fit quadratics, best fit cubics, best fit quartics, okay? So that's really what we're after today. And then when we're done with this assignment, we're going to work a lot with Desmos. It takes Desmos to do all of this, so you're going to really have to take good notes if you forget how to do it. Then you're going to be able to complete your lesson today, 6.2. Tomorrow's lesson I will get done either tonight or tomorrow. It's going to be tougher. People don't like that. It's graphing piecewise functions without Desmos, without a graphing calculator, just with your noodle, and you get it all done there. Don't forget next week. Next week's the end of the semester. Next Thursday, we're going to have our final exam for semester 1. Please remember that's like 10 to 15% of your overall semester grade. Your semester test will all be within its learning, okay? So if you want to be a model, okay, we want to make polynomial models here. So we're modeling with things greater than lines, okay? So get a graphing calculator. Probably better yet, get Desmos, because I don't know how to explain it to you, because I don't know what graphing calculator you have to try to do this regression, okay? So today's defining success is, today is a success if you leave with an understanding of a regression equation and the role a coefficient of determination plays in selecting the best regression to represent a set of data. Okay, this is things people do in real life all the time, is they model data. They're modeling data currently with the coronavirus. It increases in cases and it changes their model daily. That's why the models change all the time. Okay, so bottom line, what we're going to do here is we are going to make a scatter plot of this data right here. Now, I could plot it over here on that graph, but I'm not going to do that. I'm going to go in and I'm going to make a scatter plot right in Desmos, okay? And then once I have my scatter plot in Desmos, okay, what I'm going to do is I'm first going to perform a linear regression on the data. Then I'm going to do a quadratic regression on the data. Then I'm going to do a cubic regression. And what that does is A would be a best fit line, B would be a best fit parabola, and C is a best fit cubic that is going to best fit the data we have there. So in order to do that, what I'm going to do is I'm going to pull up and I'm going to try to remember, because I'm not real slick with Desmos, but we are going to make a scatter plot in Desmos. So here's my Desmos. Now, as you are working in Desmos, please don't forget, because I always did, what we're going to do is we have to hit the little plus button up here, and we want to make a table. And in our table, we're just going to type all our x values. I just hit enter. I got to go up. I got to hit 1, 2, 3, 4, 5, 6. And then we're going to go up and we're going to enter all those y values of 25, 90, 100, 120, 135, and 147. Notice every ordered pair should have a match. Every x should have a y with it, otherwise it's not going to be a decent data. Now, if I look over here, I don't see any of my points. Well, think about it. None of them are on here. My scale is only going from 10 to the right up to 10 vertically. So I need to click the little wrench up here. And I'm going to change my data settings because I know my y values are going to have to go at least from 0 to over 147 to see these, and 1 to 6, so I can see them all in there. They're just way up on top. So I'm going to hit the gear, and what I'm going to do is I'm going to make my x-axis go from 0 to 10, and I'd be okay with that. My y-axis I'm going to take from 0, and I'm going to take this up to, I don't know, maybe 175 and see what happens. Okay, so I can kind of see that data in there. Well, what I want to do now is I want to see a best fit regression. Okay, So how we're going to do this is we're going to click, we're going to add an expression. Now, when we're typing in any regression equations, now if I'm doing a linear, remember it's y equals mx plus b, but my data is y1 and x1, and I want to relate it to y1, x1. So I'm going to say y1, and then I need to use the little approximation, and it's just it's up in the number lines up there, next to 1, 2, 3, 4, 5, 6, all the way over there. It's on the top, so you shift and you hit that, and then we're going to say mx1 plus b, and it fits my regression line in there. So there's my regression line, okay? And we're going to take note of this regression line. And what we want to do is we want to have the best fit line, the best fit equation is going to have the most points on and closest to my model that I'm doing. So I'm only hitting one dot right here. That one doesn't really look too great. And I'll talk about all this data in here in a bit, okay? So then the next thing I'm going to do is I could probably do all of these at the same time. So I'm going to add another one. I'm going to try, I don't know if this will work, y1, and I'm going to say that approximately. Now if I have to do a quadratic, I need to think of ax squared plus bx plus c. So I'm going to say that's approximately equal to ax1, and that's going to be squared, so I got to hit my squared there, plus bx1 plus c. And I can kind of see, okay, so there's my quadratic. Now notice my quadratic is getting even closer to more points than my line did, so it appears my quadratic is a better fit than that does. And now we're going to do a cubic yet, and so like a cubic, all they do is we keep using more letters in the alphabet. So I could actually do my linear as an ax1 plus b, and then my quadratic in ax squared plus bx plus c. Now I'm going to add one more here, and I'm going to do a cubic. Well, that's going to be y1 is approximately equal to ax. Now I got to cube it, and I guess I got to arrow up, backspace, and give me a cube. And then that's going to be plus bx1 squared plus cx1 plus d would be my constant this time. And what's going on here? Ax squared. Hold on, I got to figure something out. Okay, if the same thing was going with you there, if you notice right up here, I forgot to put, because I need to relate it to my data, I forgot to put a 1 on my x. Then it's giving me my cubic, my cubic regression equation. It's this blue one. Now notice the blue one's hitting 1, 2, 3. My quadratic is hitting none, but it's really close to all of them. And my linear is hitting 1. But notice the distance between my curve, okay, my cubic. So I know linear is not the one I want. And I see my cubic graph is closer to more points than my quadratic graph does, okay? So I am going to say on a whim, and it's not a whim, but my cubic graph is the best fit for this, and it visually fits well because it's closest, this curve that I graphed, the regression curve, the points are closer in general to this line, and it touches more of them, meaning it fits the data better, okay? Now, I'm going to leave all of these on here again, and then in a minute, I'm going to talk about all these r squared, r, and these values here. So what I'm going to do is I'm going to minimize this out, and we're going to move to our next page here, and I do actually have my graphs there. Here's my linear graph, here's my quadratic, and here's my cubic. We decided the cubic is going to fit the best, okay? And that's visually it fits the best because more points are it touches more of the data points, and which means they are closer to my curve in general. So now I'm going to go to my next spot here. And then what this is going to do is this is going to be talking about, in a minute, okay, if we want to compare mathematically how well each type fits the data, we look at what's called the coefficient of determination. And mathematically, the coefficient of determination is called R squared. And the closer R squared is to the value of 1, the greater strength or the greater correlation between the data points, and our regression model or equation. Okay? The regression calculations on a calculator page will give us, okay, so we don't need to worry about that because Desmos automatically gave us our R squared, our coefficient of determination. So as I'm looking at those, I can see my cubic, I have 0.981. Quadratic is 0.879, or no, linear is 0.879. My quadratic is 0.9542. Now, when we have you guys perform regressions, typically we can get closer and closer. The bigger the power of these polynomials get, typically the better we can fit data, because if you think about it, the higher degree of the polynomial, the more times that thing can turn, okay? And the more times a function can turn, the better, the easier it is for it to get closer and touch more points. Now, we're going to make our determination. Once we hit about a 0.97 or above, we're going to say that that model is good, because the next thing we're going to do is we're going to use these regression models to make predictions. And obviously, the more terms that are in an equation, the harder it is to make a prediction and use that equation with, because there's going to be lots of decimals in it, all right? So we're going to come down to here. We're going to come back here. So I'm going to move my little speaker a little closer here. So as I'm looking at it, okay, perform a linear regression of the data. What is the regression equation and R squared value for my, we're looking here, linear, okay? So what I did was I cut and pasted just that little tidbit for my linear function here. Now notice y1 equals mx1 plus b. And notice it's telling me what the slope of my regression line is. So my regression model, if I picked a linear, would be y equals 21.857 x, because that's my slope, and we're going to make sure we round these to 2 or 3 decimal places, okay? Plus, in every variable, there's my m, they give me my m, there's my b, there's my y-intercept, plus 26.333. So that would be my linear regression equation, and my coefficient of determination, my R squared value, R squared actually equals 0.879. It's not really strong, okay? And as I moved up, notice when I have my quadratic, which is ax squared plus bx plus c, notice they give me what a, b, and c all equal down here. And that's so I can write my equation, y equals, my a value is going to be negative 4.375 x squared, and I'm just plugging these numbers, okay, right in to that equation to find my model. And then b is positive, so this will be plus 52.482x. Oh, see, c is negative, so that's going to be minus 14.5. And my R squared value for this one was 0.9542. We want to go until this is about 0.97 or higher, is I think what we're going to call. So we did say that the cubic regression visually fit it the best. And check it out, my R squared value is 0.9812. It's a pretty tight correlation. But if I had to write the cubic equation, it's going to be y equals Now I have A, B, C, and D. Notice they're all down here. So notice A is going to be 1.991x cubed. B is negative, so minus 25.278x squared. C is positive, so it's plus 115.589x minus 64.667. So you see why there's going to be an end. So when we use this equation for predictions, we are actually plugging values in for x, okay, because this is going to be my function that will predict what's going on down the road with things, okay? And my r squared here, oh, not real number squared, my r squared actually equaled 0.9812. That means it's 98.12% close to it, really, kind of. That's my coefficient of determination. Pretty good fit, all right? We could keep going and get it better and better and better, okay? So what did this data all model? I didn't describe that in the beginning. All this data in the beginning here, well, lacrosse players, okay, so they were selling raffle tickets during weeks, okay? Weeks, and then those are the number of tickets sold, okay? So what we actually do, and this is what the government is doing right now, even with the coronavirus, okay? They are finding regression equations, and they don't have to be quadratic. I mean, there's logarithmic, there's exponential, there's all different kinds of regression equations that will fit the data, and then they use that equation, and they'll make a prediction of what could happen down the road. It's what's going on right now. So what this says is, we're going to use our regression equation to answer the following questions. Well, how many tickets did they sell at the end of week 7? Well, I am kind of lucky here because I can go like, I'm going to move this down, I'm going to move this down, and I want to go like this, and I'm going to take that, and I'm going to say, I'm going to copy that, and I'm going to take that right here to my next page, and I'm going to hit here, and I'm going to edit, I'm going to paste that little guy on here, I hope, paste, and what they want us to do, okay, there's my regression equation. They actually want us to say, okay, here's y equals. They want it, because x is 7, they want us to put a 7 in for all of these x's. Okay? So obviously, the smaller my regression equation is, the easier it is for me to calculate. Okay? Well, I got all this stuff typed into Desmos already, so I'm going to let Desmos give me these answers, and I'll show you how we do that. So I'm going to grab my Desmos back here again. And because we're using the cubic, I don't want my quadratic one there anymore. I don't want my linear one there anymore. I only want my cubic. And what I'm going to do is I'm going to enter another expression. And Desmos will graph vertical lines for me. So I'm going to graph, when does x equal week 7? And see how it gives me this vertical line here. It's a pretty sweet deal. And what I'm going to do, notice I can't see where it intersects, so I got to change my y. I don't know, I'm going to get a little nutty. I'm going to go up to like 250. Aha, now I can see it. So wherever this green line touches my graph, and notice all I got to do is touch it with Desmos. Oh, well, how many are they selling in week 7? It looks like it's going to be about 188 to 189 tickets. This is what it looks like we're doing here. I really don't care if you round up or down in this application. It's kind of irrelevant. How many tickets did they sell at the end of week 7? Oh, 188 tickets. Some people are going to say, no, Kruger, 189 tickets. Okay, well, personally, I'll be honest, I would accept either one of those answers, and I think Mr. Myers would as well. So there's two rules of thought on these rounding things that we're talking about here. So that's how I would tell that. What is my next question and my final question? During what week did they finally sell 200 tickets? Oh boy. So what week did they finally sell 200? Well, I'm going to use my Desmos graph again. It's kind of nice, and I don't want to junk it up too much. Where, oh, where is Desmos? There it is. So now notice at my x-axis, that's why I said x equals 7 for weeks. Now I want tickets to find my weeks. Well, obviously it's out past week 7, but what I can do here is I can change this line I have here, and I'm just going to say, okay, so when does y equal 200? And it's going to give me my y line of 200, and all I do is click, and I click on that. Oh, 7.197. Oh, so it's not too much. It's during week 7, I would say that. This is what I would say for that little guy there. During what week did they finally sell 200 tickets? Well, it would be during the 7th week into the 8th week, right? The end of week 7, well, when I use that, I would say during week 7, which would actually be during week 8, because during end of week 7 is where we got that. So we would have to say during week 8, because it's 7 point something, so that's into the 8th week, but the 8th week doesn't end until you actually hit the 8th, okay? Because we're starting at 0 week, 2nd week, 7, so 7 point something is the 8th week, okay? So hopefully that made a little bit of sense, okay? If not, you might want to go back and watch that a little bit, and the rest of the notes on there are just really, they're explaining how to do these regression models in the CAS calculators, which you do not have. So they're easier and faster to do on Desmos. So you should be able to do your homework, and we will talk to you tomorrow. Have a good rest of your day.